Okay, so now if we're going to find our derivatives with negative indices or even fractional indices, I might do one or two fraction ones, it's exactly the same process, but we just got to get used to working with negative numbers, adding and subtracting 1 from negative numbers, or adding and subtracting 1 from fractions. So to find the derivative, dy dx is equal to, the power is 1, 1 times 4 is 4, minus, we'll rub out that there. So the power is negative 3, multiply by negative 3. So it's negative 3 times x minus 3 minus 1. 4, negative and negative is positive, 3x. Negative 3 minus 1 is negative 4. Yeah. So it is possible, we might write that as 4 plus 3 over x to the 4. Right, so that's what my derivative rule, my gradient rule is in that instance. What about in the next one? Same thing, dy dx is equal to, negative 2 comes out the front, so it becomes negative 4x. Minus 2 minus 1 is minus 3. Negative 1 comes out the front. Negative 1 times negative 6 is positive 6. X minus 1 is minus 2. So more than happy with that, but don't forget we could possibly write it as putting it as a positive index, and so we put them into the denominator. If I just create another one there and just put y equals x to the half plus 4x to the minus a half. Same thing. Dy dx is equal to, a half comes out the front, x, a half minus 1 is minus a half, plus negative a half times 4 is negative 2x, minus a half minus 1, minus a half minus 1 is equal to minus a half minus 2 on 2, which equals negative 3 on 2. Yeah? So possibly I might write it as 1 over 2x to the half plus negative 2 over x to the 3 on 2. Don't forget x to the half could be written as the square root of x minus 2 over, and I might have the square root of x, square root of x cubed. All right. So whether they're negative numbers or fractional numbers, it's exactly the same process. One last little one there, B, find the gradient of the tangent at the point where f of x equals. So find the gradient. F of x equals x squared minus, I'm going to rewrite it. 1 on x is the same as x to the minus 1. So f dashed of x is equal to 2 at the front, take 1 from the power, minus 1 times a minus is plus x, minus 1 is minus 2. So that's my derivative, 2x plus 1 on x squared. Now find the gradient at the point 1, 2. So the tangent line is really the point on the curve. So a tangent line down here at the bottom of the screen is a point where it touches the curve. And that tangent line has the same gradient. So it's just another way of saying what's the gradient at that point. So at x equal to 1, f dashed of x is equal to 2 times 1 plus 1 over 1 squared, which is 2 plus 1, which is equal to 3. So therefore, gradient is 3 at x equal to 1. All right, so I want you to do these, and then I'll be working on the sheet that I give you.